Welcome to the Crazy High Chemist. So here we are, another video in atomic structure and electron configurations. So let's get started. Bam! So today we're doing a calculation with de Broglie's equation. So let me read the question here for you, and let's do the math, because this is where it's really fun. It says, calculate the wavelength associated with an electron of mass m equals 9.109 times 10 to the negative 28 grams that travels at 40% the speed of light. So we need to know which equation we're using. We are using de Broglie's equation, which is wavelength is equal to Planck's constant divided by mass times velocity. Okay? All right, so the first thing that we're going to do is we're going to make sure that we have the correct units for all parts of this equation. So Planck's constant is joules times seconds. The mass that was given in this problem is grams, and the velocity, that is the speed of light, is going to be meters per second. So hopefully that works for you. All right, now we need to check one more thing here, and you should see that our units are not going to cancel out, and this is going to be a problem. So we need to make sure that our units do cancel out. So joules, 1 joule is equal to kilograms times meters squared divided by seconds squared. So we're going to replace the joules with kilograms meters squared seconds squared. Also, what we're going to have to do as a consequence to this is that our mass that's in grams that's given in the problem, we're going to have to convert that into kilograms in order to cancel out the units. So I'm going to place all these units in here, and then you should see that this is actually going to work here. So our kilograms are going to cancel out. Our meters, one of them is going to cancel out, and the seconds are going to cancel out, except, right? Absolutely. All the seconds are going to cancel out. One of the meters is going to be left over, and that is a length. And we are solving for a wavelength, so that should make sense for you. All right, so let's keep on moving on this problem and see what we do once we plug in some numbers here. Now remember, it's 40% the speed of light. Okay, so here I've plugged in the numbers here. I've got Planck's constant with the joules substituted in with the kilograms meter squared seconds squared, and then the seconds is there still hanging there at the end there, the other part of that. Then in the denominator, what I've done is I've taken the mass of that electron, converted it into kilograms, and I have the speed of light, that's the 2.998 times 10 to the 8 meters per second, and then it's 0.4 times that, which is 40% of that specific velocity. Okay, and then once we do all this, we're going to get a wavelength, and this is going to be the wavelength we get. And that is 6.066 times 10 to the negative 12 meters. That is a wavelength. So that's a very short wavelength, but that is the wavelength of a electron. And you should understand that we are calculating out the wavelength of an electron. We could calculate the wavelength of maybe Superman flying, because Superman has a mass and has a speed. You could calculate the wavelength of a football that is moving, a golf ball that is moving, and even an airplane. Although these wavelengths are really not going to be practical. But this equation does allow you to actually calculate those wavelengths. Okay, hopefully you enjoyed that video, and I got a super cool hat here for you, so wait for it. Hold on just a second. Bam! Okay, if you like that video, give me a thumbs up. Okay, if you like my channel, please subscribe to my videos and my YouTube channel. I would greatly appreciate that. And we're going to do some more cool chemistry videos next time. So hang on for Heisenberg uncertainty principle. Talk to you later. See you next time. Bye now.